Today, we will learn decimal numbers and tenths. We often hear in the news that the price of petrol has increased by 10 paise and diesel by 16 paise. The price of petrol in Delhi will be rupees 71 and 12 paise, and the price of diesel will be rupees 66 and 35 paise. Similarly, have you ever carefully observed the bill receipt when you purchase items from a shop? Are prices of items mentioned on it in whole numbers only? You must have seen a point being used in such numbers. We call it the decimal point. Decimal point is used to separate a whole number from its parts. For example, with the help of a decimal point, 71 rupees and 12 paise are separated. Similarly, 66 rupees and 35 paise are also separated. Numbers in which a decimal point is used are called decimal numbers. Decimal numbers are another way to represent fractions. We can say that decimal numbers are the decimal forms of a fraction. So, in this video, let's understand the decimal numbers that are expressed till the tenths place. Let's assume we call a big square as a whole. If we divide it into 10 strips of equal size, then each strip will represent 1/10 part of the whole. If we shade 3 parts out of these, then what will be the fraction of the shaded part of this whole square? Think a little. The fraction of the shaded part will be 3 by 10 or 3/10. We can represent any fraction in decimal form if its denominator is 10, 100, 1000, etc. Here, 3 by 10 is represented in decimal form as 0.3. Decimal numbers are obtained when fractions are represented in decimal form. Therefore, we can say that decimal numbers are the decimal form of a fraction. We can say that if the denominator of a fraction is 10, then to represent it in decimal form, we write the numerator first and then we place the decimal point before its rightmost digit. If there is only one digit in the numerator, then we place a 0 before the decimal point. Let's arrange this in the place value table. We already know that by moving towards the right, the value of each place is decreased by 10 times. Following this sequence, we will add another place in the table, which we will call the tenths place. Since it is to the right of the units place, the value of this place will also be 1/10 of the units place, which is 1/10. So, we can say that in 0.3, there are 0 units and 3/10. Thus, we can say that the decimal point separates the units from the tenths, which means it separates a whole from its parts. Now look at this. Here, one complete whole is shaded and 6 by 10 parts of another whole is shaded. So, we will write 1 in the units place, and since 6 out of 10 parts are shaded, we will write 6 in the tens place. This will be represented in the decimal form as 1.6. Remember that we don't write the decimal point in the place value table. Today, we learned decimal numbers and tenths. In the next video, we will learn conversion of fractions into decimal and conversion of decimal into fractions. Today we will learn conversion of fraction into decimal and conversion of decimal into fraction. Here is a square whose 4/5 part is shaded. Let's represent it in decimal form. Can you tell me how we will do this? Think for a while. Let me tell you. To represent any fraction in decimal form, we need to find its equivalent fraction whose denominator must be a number like 10, 100, 1000, etc. To find the equivalent fraction of 4 by 5, we will divide each part of the square into 2 equal parts. Thus, we will get a total of 10 equal parts. Now, 8 of these parts are shaded. So, we can say that the equivalent fraction of 4 by 5 is 8 by 10. We will represent the same in decimal form as 0.8. Generally, to find the equivalent fraction of any fraction, we will multiply the numerator and the denominator of the fraction by the same number. In the same way, we can represent a decimal number in the fraction form. Let's assume we need to represent 2.6 in fraction form. In 2.6, there are 2 units and 6 tenths. Let us consider 1 square as 1 unit. So, we will take 2 squares for 2 units. Along with this, since there are 6 tenths, we will divide 1 square into 10 equal parts and take 6 parts from it. In this square, if we combine 2 parts and make 1 part of it, then we will get a total of 5 parts, out of which 3 parts are shaded. This will be represented in the fraction as 3 by 5. Therefore, 2 complete wholes and 3 by 5 fraction are together represented as 2 3 by 5. That is why 2.6 will be represented in the fraction as 2 3/5. Like fractions, we can also represent decimal numbers on the number line. Let's understand this. Here is a number line. We have taken a few numbers on it to represent the decimal numbers. Let's divide unit distance in 10 equal parts. Can you tell how one part among this will be represented? Think for a while. You got it right. This will be 1 by 10, which can be represented as 0.1. In the same way, 2/10 part will be represented by 0.2. 3/10 part will be represented by 0.3. How will we represent 2.6 on the number line? In this case also, we will divide the unit distance into 10 equal parts. In 2.6, since there are 2 units and 6 tenths, we will count 6 parts after 2. By doing so, we will get the place of 2.6. Similarly, to represent 3.9 on the number line, we will divide the unit distance into 10 equal parts and count 9 parts after 3. By doing this, we will get the place of 3.9. Today, we have learned conversion of fractions into decimals and conversion of decimals into fractions. In the next video, we will learn how to compare the decimal numbers. Today, we will learn comparison of decimal numbers. How do we compare decimal numbers? In any number, as we move towards the right, the place value decreases by 10 times. We can say that the units place is 1/10 of tens place, and in the same way, the 10th place is 1/10 of units place. You must be knowing that on the number line, the value of numbers increases towards the right and decreases towards the left. With this understanding, we can compare the decimal numbers. For example, 3.9 is towards the right side of 2.6. So 3.9 is greater than 2.6. Or else, we can also say that 2.6 is on the left side of 3.9. So 2.6 is lesser than 3.9. Decimal numbers can be compared without the number line also. For this, first, we will compare the whole numbers on the left side of the decimal point. For example, between 12.5 and 14.2, the whole number 14 is greater than 12. So, 14.2 is greater than 12.5. Just think, if values of whole numbers are equal, then how will you compare them? Think for a while. Let me explain this. If both whole numbers are equal in decimal numbers, then we will compare the tens parts. For example, between 23.4 and 23.7, whole numbers are equal, so we will compare the tens parts. Here, 7/10 is greater than 4/10. Therefore, 23.7 is greater than 23.4. Today, we learned the comparison of decimal numbers. In the next video, we will see some examples related to tens. Today, we will learn examples related to tens. By looking at the given picture, can you find out the amount of medicine in the syringe? As we can see here, the scale on the syringe is marked in milliliters. That means the quantity of medicine present till here can be said to be 1 milliliter. You can also see that each milliliter is divided into 10 equal parts. Therefore, 1 part of the milliliter is equal to 1/10 ml. Since there are 2 whole and 5 tenths, the amount of medicine in the syringe will be 2.5 ml. Next example. Jayant has eaten 3.5 chapatis. How will you represent it in decimals? Jayant has eaten 3 and 1/2 chapatis. Here, 3 1/2 is a fraction. We can also obtain the decimal form of 3 1/2 in the following way. Since there are 3 wholes and 1 half in 3 1/2, we can write it as 3 plus 1/2. Here, 3 is a whole part and 1 is a half part of the whole. Here, we need to convert half into a fraction where the denominator must be a number like 10, 100, 1000, etc. In order to do this, we will divide the whole into 10 equal parts. As you can see here, there are 5 parts out of 10 parts of the chapati. So the equivalent fraction of 1/2 is 5/10. Can you tell how we will represent 3 ones and 5 tenths in decimal form? Think for a while. Let me tell you, 3 ones and 5 tenths will be represented in decimal form as 3.5. There is one more way to find the equivalent fraction of 1/2. In order to do this, we will multiply the numerator 1 and the denominator 2 by 5. Therefore, we will get the equivalent fraction of 1/2 as 5/10. We will write this in its decimal form as 0.5. We can also represent 3 1/2 as 3 plus 0.5, that is 3.5. Thus, in decimal form, we can say that Jayant has eaten 3.5 chapatis. Today, we learned examples related to tens. In the next video, we will clear some misconceptions related to this. Today, we will see some misconceptions and common mistakes related to tens. Misconception 1. One day, the teacher asked the students to represent 1/2 in decimal form. Manish wrote the decimal form of 1/2 as 0.1, Neeraj wrote it as 1.2, and Seema wrote it as 0.5. Identify who is correct among the three. Students fail to understand that to represent fraction in decimal form, the denominator of fractions must be any of the numbers like 10, 100, 1000, etc. Some students ignore that here the denominator is not 10, and they write the numerator of 1/2 after the decimal point and write the decimal form of 1/2 as 0.1. Some students misunderstand that while representing fraction in decimal form, the numerator is written before the decimal point and the denominator is written after the decimal point. Both these answers are wrong, so option 1 and 2 are incorrect. The correct understanding is that we need to find the equivalent fractions of 1 by 2 whose denominator is any of the numbers like 10, 100, 1000, etc. Multiplying the numerator 1 and the denominator 2 of 1 by 2 by 5 gives the equivalent fraction 5 by 10. This is represented in decimal form as 0. 0.5. Therefore, 1 by 2 is equal to 0. 0.5. So option 3 is the correct answer. Misconception 2. While teaching comparison of decimal numbers, the teacher asked Samir a question. Are decimal numbers smaller than 0? Samir said yes. Can you tell whether Samir's answer is correct or not? Many times, there is a misconception that decimal numbers are smaller than 0. With this understanding, Samir's answer is considered to be correct and option 1 is incorrectly chosen as the answer. The correct understanding is that decimal numbers represent part of a whole which is greater than 0. If we represent a decimal number on the number line, then we will observe that it will be positioned on the right side of 0. As you know, that on the number line, the value of a number increases while going towards the right and decreases while going towards the left. Since each decimal number is represented on the right side of 0, decimal numbers are greater than 0. Therefore, option 2 is the correct answer. Now let's see some common mistakes related to tens. While representing decimal numbers in the place value table, some students represent the decimal point also in the place value table. This is incorrect. We represent numbers in their position in the place value table because the value of digits in a number depends on its position. For example, in 103.4, 4 is at the tens place. So its value is 0.4. But in the place value table, we represent it only as the digit 4. Here, we don't represent the decimal point. While talking about the position of digits in numbers, many students get confused between the position of tens and tens. In 34.8, 3 is the digit of tens and 8 is the digit of tenth. It is important to understand that the place on the right of the decimal point is the place of tenth and the place of tens is the second place on the left side of the decimal point. If we consider 1 bar as 1 unit, then a group of 10 bars will be called as tens. Now if we take 1 bar and divide it into 10 equal parts, then one part of it is called a tenth. So, the digit in the place of tens represents the number of groups of 10 units and the digit in the tens place represents how many parts have been taken out of 10 equal parts of 1 unit. Some students also add the location of ones after the location of the units, although there is no such place. Tenth position is after the decimal point. The tenth part of a thing is represented as 1 by 10. So oneth means 1 by 1, which means 1, and we represent 1 in the units place only. So we don't require the oneth position, and that is why we don't show it. Today, we have seen some misconceptions and common mistakes related to tens.